Okay, for your core project in College Algebra Math 13-14, we're going to first talk about the periodic table of elements. And so it arranges all chemicals in an informative array. And the listing of elements make up all of the materials and compounds that are used in daily life. Now, each element in the periodic table has a unique history, properties, and uses. And one of those unique aspects that we can relate mathematically is something that is called the half-life. That is defined as the amount of time for the quantity of an element to reduce by half. So, and this is an important feature of elements. They can use it, for example, they can do something called carbon dating based on the half-life to look at when live organisms have died to figure out how long that they have been dead. So, in this particular project, we are going to ask you to research and prepare a report on a chosen element from the periodic table, and we want the half-life to be greater than 1 year. So, when you go in, you can just choose your favorite element, but then go in and do research to see what its half-life is, and it needs to be greater than a year. You're going to prepare a 300-word minimum report, including where your element is found in nature, as well as how your element is utilized in your chosen field of study. And so this involves you doing some research, so we need you to include citations, and they need to come from reputable sources. So try to think about where it is found in nature and how it would be utilized in your particular chosen field of study. Okay, so then part 2, you are going to use the rules of logarithms that we've studied in this particular course, and you are going to calculate what is called the K value in the half-life of the element using either of these two functions, and I'm going to show you an example of that. Okay, so let me go to the next page. So my example is using carbon, so I would advise you to choose something other than carbon as your particular element. And my research shows that the half-life of carbon is 5,730 years. So that takes a pretty long time for carbon to decrease to half of its original amount. Okay, so if I take the first particular equation that I had listed for you there, the N sub 0, that's your initial amount, and the capital N is your final amount. And so since my half-life, my time is 5,730 years, our initial amount should be double what our final amount is. So you can just kind of make up numbers for that. So in my particular example, I picked my initial amount to be 10. So think of, say, 10 grams. And so half of that would be 5, so then that means my final amount would only be 5 grams. So I'm plugging into this particular equation so that I can solve for the K value. So algebraically, in order to solve for K, I have to first divide both sides by 10 so that I can get rid of that particular coefficient there. And so 5 divided by 10 gave me the decimal 0.5. And then because this is the number E being raised to a power of negative K times my half-life of 5730, what I'm going to do is take the natural log of both sides. So when you are dealing with the number E, the number E is understood to be the base of a natural logarithm. So we spell it ln for natural logarithm as opposed to log. All right, so we're taking the natural log of both sides here, and as long as you do the same thing on both sides, it's still, it does not change the equation. But what it does allow you to do with our properties of logarithms is it does allow you to take this power and pull it to the front of that particular logarithm. So I have pulled the power to the front, And so if you evaluate the value, the natural log of E, that is understood to be 1, and you can punch it into a calculator if you want, and it'll give you that value of 1. So now it's just a matter of trying to get the K by itself. So in order to get the K by itself, I need to get rid of both the negative as well as the constant, 5,730. So I divided both sides here by negative 5,730, and then I went ahead and punched that into my calculator. So you can see on the next page that after punching it into my calculator, my value of K is 0.000121, and we're asking you to round it to 6 decimal places. Okay, so now if we go back to the project sheet, so that was for part 1. For part 2. For part 3, you're going to use the function derived in question 2, and they want us to calculate and graph 10 points based on the half-life of your element. Be sure to appropriately label each of the axes of your graph and appropriately label your graph. So let's talk about finding those 10 points. Okay, I'm going to show you an example for obtaining 2 points, and then you're going to continue in that manner to find all 10. So your x-axis is going to represent your time in years. Now, keep in mind, since my half-life was 5,730 years, then I probably need to choose some x values that are pretty large. So, for example, if I choose 1,000 years, and I plug it into my original formula, notice I'm using my K value that I calculated from the previous step. So my N of 1,000 would be 10 times E raised to that negative 0.000121 times 1,000. And so that gives me 8.86. So after 1,000 years, my initial value of 10 grams would now be 8.86 grams on my particular graph. And then I'll choose another x value. So now I'm going to do 2,000 years. Again, plug it in. So this time when I plug it in, after 2,000 years, my initial 10 grams of my carbon would now have 7.85 grams. So that would be a second point on my graph. So again, I'm using large values that I'm plugging in for my time because my half-life is very large. So kind of look at your half-life, and you're going to want to scale your x and your y-axis according to the values you have chosen. So just on a graph sheet of paper, you're going to plot the 10 points that we're asking you to plot as part of number 3, and you're going to build your graph. Now, then you're going to answer the following questions, and again, it's a 200-word minimum. So you graph it first. We're going to ask you, what trend do you see? So once you graph it, do you see a trend where, say, the graph is increasing over time, which it shouldn't be doing if we're talking about half-life? Or do you see a graph where maybe it is decreasing over time? So give at least 2 observations from your graph. So some possibilities could include your y-intercept and what that means. Is the graph always increasing? Is it always decreasing? Is there a change in direction? So your graph will have a y-intercept as a point. I want you to use critical thinking strategies to determine if this applies to a real-world scenario. So you can tell me that as part of your answer. And then discuss any negative or positive impacts of your element. Based on this information, should the usage of this element be altered in any way? So again, 200-word minimum on that particular essay part. You could either, actually your graph is going to be hand-drawn, and I would prefer that you type your particular essay to talk about these things that we're mentioning here. Be sure you show all computational work, so that part can be handwritten as well as part of your graph. And so you're going to have at least 1 paragraph, possibly more, depending on what you've got, Remember that you had a 300-word minimum on the research of your element, describing applications to your field of study, citing your sources. And then you also have you have a graph. Okay, you're going to show me your computational work to get your K value like I did on my paper. There's all my computational work there as well, so I should see that. All that can be handwritten. And then you're going to draw your graph, and then your final essay, 200-word minimum. Again, you can handwrite that if it's neat. Sometimes it's just easier to type it. Please make sure you put your section number with it on the paper, and then I just wanted you to see the grading rubric. So I will go through and look at, are you within the parameters of your element, meaning that the half-life is more than a year? Did you identify proper usage of your element in the real world? Did you correctly calculate your K value? And I've got to see that work to support it. Okay. Of course, looking at your correctly calculated 10 points of your graphs, I want to see that work. Are they correctly plotted on the graph and appropriately labeled? Did you discuss the trends of your element? Did you provide 2 correct observations about the graph? Did you use your critical thinking techniques when discussing the chosen element? Did you address the y-intercept and how it applies to your chosen element? Is it clean, mainly free of grammatical errors? And do you have sources that are correctly cited? And you can just cite those at the end as a works cited or bibliography, whichever you're used to doing, depending on if you're using APA or MLA style. So I look forward to seeing these great projects. They will count towards your grade, and I've got a place where you can upload them. So email me if you have any questions.